All right, so this is a video that shows you how to conduct independent t-test using SPSS. And I'm going to use the sample data that I entered in the video that's in the week 3 folder about how to enter data into SPSS. So what you can see here is I have one independent dichotomous variable, which is gender. I think I gave males a label of 0 and females a label of 1. So we got 10 males and 10 females. And then we've got a dependent variable that's measured on an interval ratio scale of height, and another one that is weight. So if you don't know how to open up your data set, your data that you've entered into SPSS, if you can't figure out how to open that up, send me an email and I'll show you how to do that. But I think you just double click on that data set and it should open up in SPSS. So now to do the t-test, we go to Analyze and we go down to where it says Compare Means, and then you move the cursor over while staying on that line to Independent Samples t-test. Click on that, and I already did this once, so I'm going to show you how to do it from scratch. For the independent variable of gender, that's our grouping variable. And when you put it in there, it says define groups. And that variable has two groups. One of them's got a value of 0, the other one's got a value of 1. And so you enter 0 and 1 there. 0, 1, like that. And then you say, what are the test variables? That's what SPSS calls the dependent variables. And so let's do height in inches. Let's see if these two groups of males and females differ in their average height. You can click on options if you want. This lets you decide what percentage of confidence interval to do. SPSS automatically gives you a confidence interval. Well, you can do 95%, you can do 98%, you can do 99%, whatever. So the default is 95%. We'll stick with that. And then you click OK. And then you get SPSS output, and it looks like this. N is the number of cases. We have 10 males, 10 females. The mean for males is 70 inches. So on average, the men in this sample are 70 inches tall, and the mean for females is 63.2 inches. You get a standard deviation for each sample and a standard error of the mean for each sample. And then you go down here, and this is a little bit confusing. The first test is this thing called Levene's test for equality of variances. And this is just to see whether the variances in the two samples are equal. Basically, whether the standard deviations for the two samples are roughly the same. If they're not, you got to do a little adjustment. But this test, if it is statistically significant, meaning if this sig value here is below 0.05, then you would need to read this bottom line, equal variance is not assumed. If it's not statistically significant, and this test is not statistically significant because the sig value, this is the same as a p-value, is greater than 0.05, then you just read the top line, equal variance is assumed. Then you get the t-value, you get the degrees of freedom. Notice the degrees of freedom is 18, which is 10 plus 10 minus 2, the two sample sizes added together minus 2. Sig, two-tailed, this means the p-value of the two-tailed t-test, is 0.000, meaning it is highly statistically significant. And the 95% confidence interval ranges from men having an average height that is between 3.67 and 9.92 inches taller than women. We are 95% confident that the actual difference between the population means of men and women, or males and females, in height ranges from 3.67 to 9.92 inches taller for men. So notice that in our confidence interval, there's no scenario in which women are taller on average than men. And this tells us that our difference between our sample means is statistically significant, It probably did not occur by chance, and that's what this sig value tells us as well. So that's how you interpret it. You say the p-value is below 0.05. The difference between the sample means is statistically significant. Therefore, I conclude that the population means are different, and on average, men are taller than women. Ta-da, that's it. So that is how you conduct the t-test and wrap words around it.